I think we are live. Hello. Hello Dishipu, hello Dutch, hello Yombo, hey Johnny, hey Jody. I hope so, I don't know. You have to make them blink. So Fu certainly sent on Discord a few games for the LED matrix, and I thought we might want to try. And hey Sonic. So let me check. Let me show you Discord what we got there. I got pinged by. First of all, we have like streaming Doom by Morn. I hope we can make that happen today. Then where is it? Showcase. Fu will join later and probably. Where is it? Can't find too many channels. I will remove all the showroom. There it is. Here we go. Alright, how do I close that? Yeah, anyways. Here we have Bad Apple on Python. Then we have Snake. Then we have Pong. And we have Breakout. And Space Invaders. Seriously? Okay, so yeah, there will be some stuff that we want to try today. Can't you just put 8 transistors on your PCB to make them brighter, or what? What are you? No. What's going on? Oh yeah, Yumbo. No, if there is an 8-byte SRAM chip. 8-byte SRAM. Not bits, yeah. Yeah, you need to put shift registers on. You can just use like 595 595 shift registers. 16 transistors, still not enough. Hey Basil. So by the way, the script is recorded, so the voiceover, Basil, you get a mention as expected. If we can record, stuff today. If we can record anything today, we can put it still in the video, but with no voiceover, so we need to talk about that. Okay, here is something that I wanted to share first. If you're curious, I assembled it today. Didn't plug it in yet, and didn't try yet. I hope there was no shorts. Nice board. Yes. It's the programming board for the cluster cards. So we will plug in each individually and then let's cycle it through. I had to salvage those chips because apparently I couldn't find them in my chaos from magnet matrices that I didn't use. So, and I hope it works. And one thing here, this is, by the way, yellow pin headers, I don't know. There. Yeah, so yeah, I forgot to get Enic finish here. that's hassle. It will be alright though, I hope so. The issue might be that that's like different soda paste compared to what I want to do. It's quite close here. I hope I don't short it. So I mounted, like I pasted the footprint of this header today and placed it and reflowed it, and it had like bridges underneath the connector. So how do you think I removed those? Hey Kaspar. Is that a PCI Express ×1 connector? No! This is M.2. That's an M.2 M key. So that's twice the pin density. I can show you the card for comparison. This is PCI Express ×1. Yeah, it's the same size but half as many pins. Yeah. And that's like over 60 pins. You were in your bed, went lazy watching today. No, did you grab a tea? Kasper. Nishai, hey. Welcome to the stream. Eisenmochi, hi. With a wig? No, I didn't remove it with a wig. I put it on a hot plate and pulled the connector off and put some flux on and put a new connector just on there. So and that apparently was all right. So I will probably, when we assemble this one, I will probably focus. Yeah, I will probably paste it, then reflow, and then put the connectors. Hey Sonic, thank you for the sub. And then put one by one on there. The bad thing is there is no way for me to inspect the connector that I just put on. So either I will have to probe it with needles to check X-rays. Yeah, that would be good. Yeah, I don't have X-rays. I'm sorry. I don't know how else I could test that. I would need a specific card where I can a specific card that tests if there are any shorts. All at once? Yeah. No, I will. That will work. I do a too crappy paste job for that. So I will certainly put those on a hot plate and then put them on one by one carefully with a lot of extra flux, and hope that there is no short, and plug it in and see what happens without any of the cards plugged in. I mean, we can test stuff, but no, where do I get my flux from AliExpress? And I ran out of flux. I forgot to buy a new one. I have only the stinky green one, which everyone liked to see, but I get headaches of that. And hey Z80. And I have different ones that are quite good. I mean, both of those were good, but they're now gone, almost gone. I have only a little bit in the tip here. That will be probably enough for this project still. This one was good. China trademark number. Yeah, 559 ASM. I don't know. That's like, and this one here is, this was, I don't even see, this is like a darker paste. I could probably get some from this syringe, but yeah, the plunger is all the way down already. RMA, I don't know what the difference is actually. Liquid, yeah. No, this one is my favorite, the brighter one, like the not the dark brown one. Don't trust that much. But, I think the darker one is BGA, is it, or other way around? My new paste arrived here. This one here. I tried it today and it was good. I like it. It's not like I don't know. I don't think it's water soluble, so it probably has like flux in that. I liked how it performed. It was more pasty, not smearing around. Oh yeah. Here. The comparison, size comparison. Here, old cluster, new cluster. Look at that. These are okay. They have. Oh no, this one is bent already. Yeah, I can bend this back. But aligning those connectors properly, and this is quite difficult. Half the size. No, it's quarter the size. Like actually it's 22 millimeters and this is 40. So not like, it's probably 1/3 like area wise, including the connector, and you have like these connectors, pain in the ass to solder as well. But at least you could solder them without bridging, or you could fix that with. Yeah, and this will be. Yeah, this one is really tiny and plugs in this connector, and I hope by next week we will have something running on that. I hope we can test this today and that it runs, and then the only thing, once this is running, I only need to get this running, and then we have a video. So a lot of editing and figuring out, and I need to release them from the frame, because JLC wouldn't be able to pick and place boards that are smaller than this size. So I let them frame up the boards, and I really need to be delicate removing them from the frame, because yeah, there are traces really close. So I have 20 of those, but we only can place 10 here. So maybe I can even assemble 2 of those. Who knows? Who knows? I expect I ordered 20 because I know if I would use like 16 to have a 256 core stack backplate. Oh yes. Yeah, so size comparison, I need to zoom out. Here we go. So this is okay, it's a little bit different, because on this one you have like 32, and then you have a lot of GPIOs. So you got like that, and this is basically the same like the 5. Yeah, that's different stuff. And we would have like 5, so here. Um, this would be, because this can only plug in 10 boards, that would be 10, would be like this size. And a lot of GPIOs, but interesting with the new design, um, I used, instead of having a lot of GPIOs, I added 8 bits to the bus system here. So this is 16-bit bus, plus it has each card has a separate pin for 2 GPIOs. So actually there are GPIOs. One GPIO is used like for the is shared with the LED, and so it can do nothing very fast. It can do stuff very fast. Here for one of the GPIOs we have an individual pin. So this board actually uses the GPIO, and you could use it as an ADC as well. So 16 ADCs from this card. It's probably noisy as F, but yeah. It should be versatile. I don't know. I wanted to have like an address bus maybe. That's why I took 8-bit for data byte and 8-bit for addressing maybe. It's like an FPGA maybe. I don't know yet. It's just I don't know. But I'm looking forward to have this one populated with the sockets and plug it in. Yeah, we could try. I never plugged it in. We could plug it in and see what happens. The CPUs can run at 48 megahertz. So yeah, 48. The main CPU that's on here, the controlling one, and that's here, can run 144, I believe. So it can do extra stuff. Yeah, these are like more or less MOSFETs to turn on individual power lanes. So we can turn off on this card. We can turn off each, like turn on and off in each individual MCU. That's hopefully not be powered like from stray leakage GPIO currents or whatever. So we can program them individually without any problems. I hope so. So that was part of the design. And this will go in there, and we have then a blob of clusters. Speed is only really faster when running from code from RAM. The wait state required flash. Yes, I'm talking about that. Basil, it sounds like we would need like to, like you would need a device like that to be. I mean, we have Luniasm, and maybe that could cross compile to be run from SRAM, because I want something to be. I want these things to be able to run code that's transferred over bus. So running it from RAM might be actually useful, and there is not much RAM, but we have an address bus, and how it I don't know. Okay, let me get the power supply. Oh wait, yeah, I wanted to plug it in, so let's plug it in and see what happens, huh? First of all, this one here, if we can hear it exploding. Uh-oh. I can't hear anything. Does it run? I didn't put an LED there. I have no clue if it runs or not. We would need like to let me connect a linky first, so we will see if we can recognize it and program it. Here's a linky. And I have even some labels, at least here. Oh, I need to put some jumpers on here, but these are not. Oh wait, B2 ground. B2 is boot 2 to ground. Yeah, I need the jumper there. Otherwise it wouldn't boot. Where are my jumpers? Here. Here, Johnny, pink jumpers. I have 1000. When we will see the magic smoke. Oh wait, that's V. Weird constructor, hey. Didn't see your name here before. Welcome. Okay, pink jumpers and pink font is endless, yes. I will add, I'll put the, I think boot needs to be pulled down, boot 2, to properly boot. That's that. What else do we have? Yeah, that's the programming pins for... Oh, you're Lurker! Nice. Nice to meet you. Wait. Oh! Here are 16 LEDs. We need to bada boom. Big bada boom. Yeah. Negative volt. Damn. Where are my jumpers? Must be in here. If I didn't, okay. I just take any other. Oh, wait. Here's a linky with jumpers already in place. But these are not enough jumpers. I need more jumpers. Okay. And I need an extension for that. Oh, wait. There is yet another linky. Okay, enough linkies here. So. Linky. Now. Oh, PCB printer. Wow. You're actually doing that? You probably bought the same one that Johnny has. Downvotes? What? What is going on? Is there? No, I see like 6 likes. Downvotes for what? What? What is going on? Haters gonna hate. Yeah. Australian audience, maybe. Holy flame, that's a good one. Welcome, by the way. You're also a lurker. Nice. It's gone after reload. Yeah, it was a glitch. It was a glitch, my friends. Do we have a reset? That's ground, 3.3 volts, ground, clock. Oh wait, we would need like another pin here. So maybe let's do reset. This will be clock. Now you can see here, and I will take this one ground. All right, whatever. We wait. As soon Fu arrives, we will switch to the matrix again. Oh, by the way, we can replace the resistors and make it brighter, hopefully. I got the Reichelt Lurkers Rush. Nice, yeah. So this is ground. Why do I no wait, this is ground. Not reversing here. Ground is here. Okay, that's ground. We only need 3.3 volts for now. That's here. Then we have the reset that actually does something sometimes on this board. Then we have blue is I/O and this is clock. Okay, here. A lot of Australians. Okay, I hate to pull off my stuff, pull off the table. Almost lost the screen thing here recently because I stumbled across my smoke. What? What did he do? Wait, huh? How does that thing work? Oh yeah, they did. They did. They actually did make these here, which I wouldn't like to assemble myself because it's all 4 or 2 components on there. But they charged me so many extra charges for, yeah, that's tablet stand for. That was actually one of the. This cable is so stiff. Ark. Yeah. Anyways, We don't need that. We are doing a different project. Concentrate, Looney, concentrate. Where's the Morn River? Morn River Studio. Here we go. Okay, M.2 matrix. How, we just clone it, do we? Copy. M.2 cluster programmer. Okay, I hope it's copied properly. Let's see if it's detected. I can't run. Okay. Cluster programmer. Oh, it even opens that. No. All right. Here we go. Yeah, we don't need all that stuff. That's like matrix reading, writing. That's reading, writing USART. Often the most creative people have a messy work environment. Yeah. That's a urban legend which is kept up by messy people. Okay, we don't need frame. I just remove all the... That's not necessary. We don't need that. We might want that. Not sure. That's the C driver. We might want to keep the pin configuration off for now. As well. Wait a second, USAT config. That's interesting. Okay, yeah. Here we go, because that we can keep the USART config. Push-pull mode. Okay, we keep that. That's setting GPIOs to write. We don't want to show anything. And we actually don't need that. We don't need that. And column, next frame, we only need frame time, frame bits, x, rest, dip, bef, ticks per bit, which is tick. Ticks. I don't know. I just do ticks. Ticks here, because that scales if I do anything else, and this can be removed. Column bank, that's pin bank, and we need, let's check what we need for that device on KiCad. So this is the cluster programmer. We have, oh wow, okay, we have all the grounds. So here we go. That's ground. Oh, I changed the order. Oops, you can see. Here we go. Yeah. Okay. The order is just so the traces would be even possible to put on the PCB or easier to root. That's why it's chaotic. But we can take that. I will just put it on my other screen. You can't see anymore. But we will be using those grounds. So we have GND bank, and I will use GND0 is PA0. So I think we are using A for everything except A and D. So we have 8, we have 16 GPIOs, which are D and A and D, and I think, yeah, that's the same. Now I need to check which ones are we using here. So it seems like I still kept the pairing with A1, A0, A5. Oh, interesting. Up to A8. Is there A7? A6, A10. Oh, and then we have only D4, D3, D4, D5, D2. It starts at D2 and we have only four of those. Okay, so actually it's all A here. A, and A. And that started at 2, 3, 4, and 5. Was it? Yes. Wait. Check D4. 3, 2, 5, 6. Wait. Where's D? Oh, 1, 2. This is like a note. A. Oh, there is no A11. Oh, interesting. It's an odd number. So 2, 3, 4, 5, 6. And we have 7, 8, 9, and 10. Yeah, looks like that. Okay, so that's G and D. So we can power it up. Now, button. That's const. That's also const. And button pin is 12, I think. Yeah. PA12 is the button. No, PA15. Okay. 15 and bank. Bottom bank. GPIOA. Boring. Did you fall asleep already? Okay, because we have more. We have 2 buses here to cover. That's just PB completely. So bus, and that was PB. I added the jumpers here because that are potentially the programming pins, and we don't want a pull up there. I don't know if we can use it, if the Linky still will work with the pull up, maybe, but I made it optional. Not sure about that. Have to test this. I didn't want like to have to botch anything. Can remove it maybe from the next revision. Will be a few less pins to care about. Oh, tabs. 7, 8, 9, 10, 11, 12, 13, 14, 15, and this will be open collector. So first of all, GPIO B, C, and D. Then grounds. That's spaces. Okay. GND bank 16. It's const. It doesn't like the const. Yeah, because you can't write to const, huh? It needs to be defined other way around. The const needs to be the address, not the GPIO. I don't care. Should it can copy the block. I don't care. This will be alright. It has nothing more memory. Yeah, that was that. Bus, I don't think we need bus, but we can do the button. Button, we don't need to set it up to the read. GPIO mode in floating button bank and pin is button pin. Okay. Does it use, I don't think we even need usart here because we're using the pins for something else. This is like different, yeah, TX, RX, no, that's PN. I think it's somewhere here, the usart stuff. Was it A? Anyways. Yeah, USB A11 and 12, that's why we use the other stuff. Alright, so no usart, this will be it. We won't be reading anything. To turn off that. Maybe. Yeah. If did we do the button pull up by default? Or is it here? Yeah, it's pulled up by default PA12. So if PA15, if GPIO, wait, button bank, yes, in the R ref right shift and 1. Button pin. So it's pressed while not. Yeah, we can do that. We should wrap this in a function. It screams for a copy paste error. We wait. Bounce. There will be bounces. No, I added actually a capacitor, so it should be debounced. Even that. And then we will move on and try to cycle through the grounds. So here it comes. I hope it's not inverted. So we will do GND bank, and we also need to write GPIO. Okay, bit reset. And we need a static. So whenever we press the button, we cycle through the MCUs. let's say static MCU active. It's not active because, alright, but we can do GPIO. Yeah, we don't need to. Current MCU. Oh, we put it here. Resets, and then we add MCU and we set that. I hope it's not inverted, otherwise we will just invert this here. Okay, so it will be, everything will be turned off. Okay, we start with 15 because everything is turned off, and then it will start cycling and powering up the individual MCUs, and we can test that with multimeter. Okay, moment of truth. Code protect status disabled. What? Okay. Yeah, whatever. Apply and close, and then we can download. No delays. No, yeah, no delays. Wait, that was it? It just uploaded? It's just working? No way. Okay, multimeter. If we will be able to program if we will be able to cycle through the MCUs and upload an individual. Oh, fool! It's forgot to turn it off. Okay. How do I test the individual? Where is ground here? I don't know. Ground is, here is ground. I think these three are ground. Okay. Good joke. Okay. So so there will be, I don't know what is this. This is terrible to play around with. Okay, let me get a clamp or something. You never joke. Jokester. What do we have here? Nope. No. Oh. My neck is stiff somehow. I don't know what I did. Oh wait, I know what I did. Okay, I will just plug it into ground. Wait. Okay, ground. Do we have a different ground here as well? I hope it's not a floating ground, it's actual ground, because that might be a different ground. Let me check here. So what ground do we have here? No, it's actual ground. Okay, wait. So I'll be able to test okay, where's the... Need to check with the schematics. The third one is PA0. Okay. I press the... Let me record that. Press the button. Nope. Nothing. Not even shortly. Yeah. We need to find out. PA is always also pain in the ass. It was, at least. Let me think about it. We can also test D. Which one was D? PD4, PD3. D is the fourth one. Why is it? Huh? Why do we even have... Like it seems like it's floating or something. I don't know what's going on here. Is it running? Is it booting even? Where is the code? Huh? Did I close it? Huh? Oh, here. We can also init delay. We can do delay init remove the sysdig stuff because that uses delay, and just cycle through. Oh, what is this frame position? We don't need that. Leave that out. Delay. Okay. Let's try that. Wait, I left it here. Did it even compile? Did I upload like some crap? Might have uploaded some crap, like empty thing. Oh man. Target file doesn't exist. Okay, now. Wait, huh? Oh wait. I need to. Huh? How did we upload? That's the wrong file. It didn't compile. Oh damn. So bad. Okay, here we go. Now it it might have worked all the time. Okay, peeps, try again. Lol, uploaded wrong firmware. Yeah. Damn. It was running the matrix code. Ah, cringe. Cringe moments. Here we go. Let's see if matrix appears at some point. Zero, zero, 16 seconds, every 6, there it was, and now it's gone. Never happened to you. Okay, it's running, now let's buttonize it again. Let's buttonize it again. Meter, yeah, it's slow. But you know it's working. Okay, we don't need delays here anymore. I should close all other windows. Close others. Boom. Gone. All right, upload it. Okay, I take it. Now, it's still recording. What a fool. Okay. Now, it's 0. I press the button and let's see what happens. Here we go. 3 volts. Yeah, it's a little bit on the weak side. And now it's off again. I have to press 16 times. Here we go. Here we are again. And off. Nice. That's working. I will test the other side though. What happens here? Millivolts. Okay, that's floating now. Because that's on the other side. No, it's to power 16 individual MCUs. Why is it? Oh, wait. I need to VCC and ground them as well. So I need to change the jumpers here. So it uses the same VCC and ground. Here we go. And because we could use another linky ground and VCC, so it will power cycle. Everything is well thought through here, except for the placement of this meter. Okay, here we go. Let's try again. Floating, floating, float. Ah! Oh no, I skipped it. I was too fast. I didn't count even. Here we go. What is this? Oh yeah. It's floating. There is no sink. I didn't plug it in. But it seems to work. Okay. Do we actually plug in a matrix? Should we plug it in? It should probably is not hot pluggable. Okay, peeps. Okay, let's plug it in. I hope I didn't mirror the pins or whatever. Moment of truth. Here we go, peeps. It's okay-ish. Is it getting warm? Is this warm? Okay, let's cycle. I hope to see 3.3 volts here at some point. This one, it seems, did it crash? I don't see. Yeah, healthy anxiety. I don't see I don't see. Oh wait, that's a sink. Oh, I'm measuring on the wrong side. Ah, yeah. Let's check if we still have some power. Because this is like the sink side, not the power side. Wait. Yeah. Okay. Well, we can connect a linky and see what happens. Then how do we do this? We need a firmware for the mini matrices. I have now anxiety over this. Okay, wait. Let's do the following. Let's power it from a USB port. And do I really want to remove? Okay, let's remove that. Okay, I hope, because now the linky, we can use that to program stuff. Where's the probe? Okay, let me probe if we got 3.3 volts. Yeah, 3.1 is so good enough. Oh shit, oh shit, oh shit, this is getting hot. Did I serve it with 5 volts though? Might be. Oh, I hope I didn't break that one. Shit, let me check. Now I'm sweating. VCC and 5 volts. Let me check that. No, that's not it. Why did it get hot? Something's off when I'm running it from 5 volts. Here, on that one. I hope I didn't break this one. Can't be that. They should be off by default. If I plug it in, unless, what could be the issue here? What did I do wrong? Yes, it did get only hot when I powered it from USB, but that doesn't... It was warm when powered from 3.3 volts. Okay, let me get ground. Okay. No power delivery. Resin vaporizers. No, I have a thermal cam. I'm wondering what was happening here. Okay, let me plug that in. What? How do I? No, it was USB. So there is some power limitation on USB. VCC, wait. Why did it get hot? They should be all turned off. By default. Or are they? I mean, that's inverted. No. Yeah. That's basically it. So they should be. Oh wait, no, they're all on. That's an inverted signal. Yeah, we can move to the bench power supply. I should also invert the signals though. So I might want to. Yeah, but we have thermal camera. That's all right. Clock is this. I/O and clock over here. I need to invert it so they will be turned off. But what is the issue? No, that's not it. They never should be like getting so hot. That's certainly not it. I tell you 100%. It's not what. Ground inverted. No. No, this is correct. Because that's like if we do high, and it shouldn't be. I don't know where the current is coming from. I'm wondering if there is it's getting warm though. Oh. Yeah, it's getting warm. I need a thermal camera here. I'm wondering where the current is coming from. Something's off. Maybe I got a short on my programming board. Thermal camera. With 5 volts it was just like with USB we just had more current. I think it might be like with the USB. The Linky has a little bit limited current that it can provide. That was protecting it. If the short is on the board, you might have like plus minus inverted or whatever. Or the board is getting hot actually, not the... Where's my thermal camera? Here. have a PSU with current limiting features. But it's over there. I hope it's not broken now. Okay. So yeah, let me focus here first, like that. Focus here, and then oh, there is one that's getting hot. There was one specific MCU that was getting hot. Do you see that? Oh no. No. Oh, I didn't record. The sun is rising, okay, for the camera. Huh? Now it doesn't do anything. Huh? Ah, here we go. Yeah, but it's only 24 degrees right now. Okay, now it's 40, 45, 47, 50. Okay. So yeah, no good. It's the one MCU, but we can narrow that down. You bet it's rotated. The MCU? No. Can't be. Should we try another I will try plugging in another one. They shouldn't be powered at all. It shouldn't be powered at all. I don't know where the power is coming from. Yeah. We might need to open. We can test which one it is. No, it's not rotated, at least on the spare one. No, it's not rotated here either. Maybe that one is already broken. But how? Why? I hope it doesn't. That we have like a better success rate than 50% with those matrices. Okay. Should I plug it in and see what happens? I mean, we can. I will plug in the spare, and then we will see what happens. Okay. 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 Yeah. Nothing. Let me try again. Oh! Another one! Oh! Interesting! What do you mean bites the dust? It's not... What does that mean? Okay, maybe we can identify with KiCad what these two have in common. Solder bridge? No. Why would it be a different one this time? Okay. So we had this one here. Why would it heat up? Does it leak like current somewhere else? They should all be like off. I mean, this is G8. G8. VCC. We can test that. Okay, I unplug the card. Okay, we have VCCs. They're on this side, I believe. No, they're both sides. Okay, this should be 3.3 volts. Okay, wait, you don't see anything. So this is VCC. Yeah. And this would be, yeah, I can't poke around with this probe here. I need like a needle or something in a microscope to test that. Why does it heat up? I need to find the reason on the main board. Breakout board, yeah. This is not good news for us. Cluster programmer. Strange, yeah. So, hey DFGA. The breakout board is like, I would need to order a new board for that. Or I solder like super thin wires to one of the connectors. I have a few connectors spare, maybe. So, but why would like two different MCUs heat up? Are they maybe okay, what I can do is I can take a look underneath the microscope. So let's switch to, or let me look at it shortly, and if I can see anything, now they look perfectly fine. Like a perfect job. It was also so random them to light up. Yeah, that's what's happening here. So the GPIO turns on the ground. So unfortunately, I don't have like the high side is always connected to here, VCCN. What we can do is we can disconnect VCCN and then connect it to the linky. So the linky would be controlling that. But there is no way to turn off the high side. Maybe I should have used the high side instead of ground, because ground. But what would be where? What happens? You know what could be happening here? Yeah, so but we can check what happens with if there is a case, if low side is off, if it would invert. High voltage drop. Oh, I checked the 0.5 volts. What the issue? The issue is that a random, from our new cluster cards, a random MCU would just heat up. And what I don't know is, okay, yeah, that doesn't help at all, is if I have power here, these are pulled up. Yeah. If the current is flowing in the other direction some form or way. But how? Why would it heat up? We have VCC here. What's happening? Maybe there is like some strange, because these are so many, maybe there's some strange thing going on where the voltage just bounces around and we get like 20 volts step up converter by accident. Very odd behavior. Why is it these specific ones? It's not like yeah, enabled state, but what would happen there? Would it draw like too much current? Yeah, there are different places. I can show you again. I mean, it would be strange if, I don't know. Okay. Plug it in again. I recorded for 15 minutes. Damn it. I turned it off by 50. Yeah, I can do that. Wait. I can go really close and focus. And zoom there in. Here we go. Wait. Okay. I plug it in. Here. Oh, it's the lowest one. Okay. Was it the lowest one before? It's just getting hot. What the F? Was it B3 last? Oh wait! It was a different one. But now it's stable. Yeah. It stays the same. Whichever one boots first, you say. Maybe I should get rid of this. Yeah, this board is this board was like A2. Nothing. Oh, sorry. It's getting... Is it reflecting like the edge? Why is the edge glowing here? I think that was a reflection. Okay. Nothing. Maybe it's just variation when I plug it in. Does it short out or whatever? Nothing happens. The hustle finish is maybe not the best choice here. Yeah. Is it alive? I don't know. We need to program it. Okay. Let's try that one again. Yeah, I know, I can turn off the 5 volts, but I'm not using the 5 volts here. The 5 volts is not connected. I'm just using 3.3 volts. Because I know the 3.3 volts is current limited. Still enough current for that one to heat up. Nah. Double TV! Yeah, that could be it. It's just shorting MCUs. I don't know, this matrix worked, but this one heats up for some reason. What did I do wrong here? Maybe I have a short on the GPIOs here. Nope, doesn't look like that. It looked like we had a different MCU once, and on the other matrix it was a completely different one, but then it worked. Yeah, current limited at 1000 ampere. Yes, that's what I. Okay. I don't even know if I plug it right, plug it incorrectly. I hope so. I will shave off the excess mouse bytes here. UNL is suitable or only 5 volts? Are you kidding me? But it's a low side and oh yeah, it doesn't matter. It shouldn't be turning on at all. If I drive it like with 3.3 volts and it's not suitable for 3.3 volts, then it shouldn't turn on. It should maybe heat up or whatever, but okay. That plugged in correctly, hopefully. I should be recording everything in case it blows up again. Please read the manual and tell me if they're inverted or not. It oscillates. Yeah, it might be it. Okay, that one doesn't heat up anymore. They are inverted, but what do they invert? Do they invert the ground, or if I set them high, will they go low? I mean, will the base, no, the gate be active, or Jumbo, will the gate be high? Or is meant with the invert, because the symbol here just says it's like an inverted buffer, which means nothing but that if here 3.3 volts, Darlington array drivers, they don't have a gate. Okay, base, whatever. So because that looks like a buffer, so it should be low if I put high on this side. That's like an inverter here. Do I see it wrong? Arc. I can activate them all. Let's invert it then. Active low, okay. It's your responsibility. If input 1 is high, yeah, that's what I meant. Dutch, Jumbo. This is what I meant. Shouldn't it be like that? That was my interpretation. I'm open to testing it, to turn them all on. Oh wait, before I program it, we can try something else, okay? We can try turning on the camera and then just flipping the button. If we can actually activate the pixels. Aaron, like Aaron said. Let's activate the pixels. I'm wondering if, like, where we saw, if it was like a strange... Where's the camera pointing at? We can't see anything here. The outputs with a multimeter. Yeah, how do you measure an output, like a low side output? Okay, let's plug it in and then let's... Have you tried to not screw up? Yeah. Pull up? No, what pull up? On the... No, there is... Wait, okay, here we go. But this is terrible with this camera. Okay. Let's focus the camera. And the main MCU is running hot here. Not hot. I will press the button. Open collector. Okay, button does nothing to them. All right. I will be doing the following. I do VCC is turned off, and we can use Linky. Wait. Or I will use... No, ground will be okay. Okay, so clock. Oh shit, that's voltage. I will try to get hold of like VCC. This is the clock. And reset. Reset, okay. Let's see if the Linky can actually access one of the MCUs. I need to check if nothing is overheating here. Okay, nothing's overheating. We can start the external tool though. So it'll be a pain in the ass. I should have used high side and low side at the same time, just to be sure. But there is no way. I have like... Ah, damn it. Might have been wrong decision. Where is the Mon River Studio? Here we go. Okay, link external tool. Yes. No, not enables. There is no enable. It's connected to ground, to the ground of each of the MCUs. Okay, so okay, we connected to the linky. Okay, we can't get a connection. Now I will press the button. One of the MCUs should be active now. Still nothing. Uh-oh. Is it power cycling? I hope not. Stop mode, reset, disables the... Ay, 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 ay. Oh, wrong chipset. Yeah, you're right. Here we go. Yeah, but it would read that as well. Uh-oh. Ay, 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 ay. How do we fix that? Yeah, read one chip. It's what I'm trying to do. I mean, it should be booting one. Our code should cycle through the chips. Here, when I press the button, it should just activate a different ground. But I think the linky is rebooting. Yeah, no, but I'm not running the program here. I'm not running the... I try just to get the chip info. Let me check configuration. Wait, supercluster. I think, oh, yes. Okay, we can copy that. Paste it here. Supercluster, yeah. Wait, what? Oh, okay, that was the wrong. Use default, okay, whatever. Can't you measure the output? But what do I measure? There is like ground to ground. If I could plug in an LED and see if it lights up, because on the other side of look, so this is basically ground. If I measure here, it will be oh yeah, Okay, yeah, I could. Yes, I could do that. I mean, we can beep it. Basically, continuity test. Yes, let's do that. But then I will need to unplug the card because I don't want to mess around with that. Okay, let's unplug. What I could try to do is let the device boot and directly enabling the first MCU or something. Okay. Concentration. Yeah. Here we go. Okay, you know what? I will screenshot that. I will screenshot and put it on Discord, okay? If you find a bug, tell me. Where do I can give you the link to the Discord image. I have no like drop thing or whatever. Fax it, yeah. Here we go. Oh no, it's completely. I hope it's not. It might be distracting that it was all selected. Okay. Here we go. No, I won't send emails out right now. Here's the one. And I give you also the cluster card schematic. Which, oops. Someone maybe can drop the link, or I will just drop the link, and I just need a subsheet here. Oh, not that. Snipping tool. Okay, here we go. Yeah, all levels of. Wait, I can get forward. Open in browser. Here is it for browser. I don't know if it works. Okay, now trying to do what was suggested. Continuity test. Oh wait, VC. Yeah, that doesn't matter. Doesn't do. Can't hear it. Yeah, I left the jumpers. The jumpers can be used to like split, to use a different. Doesn't make sense because then you can't like switch it properly. But if I want for some reason to power it from Linky or power cycle it from Linky, that might be. Suppose they're jumpered here. That's jumpered. Or do you mean like? Yeah, I can do that. It will be certainly floating. Yeah, we have like here. It's floating and 600 milliamps. Why does it show 600 milliamps? Yeah, that should be right. But why does it, I mean, it should show 0V, but it shows 600 millivolts, and I don't know why. Yeah, that doesn't help. Do you think it's like oscillating or what? Body diode. Yeah, it's the drop, yeah. I think also it might be the drop. So logically on the other side, the voltage is 0.6 volts higher. It's so strange. It's not logical because it's floating. It theoretically is floating. How is that possible? It generates negative voltage because the voltage drop. It's like law of physics. I would also say, I mean, that's two consecutive, like Darlington is like two transistors in series, free energy device. I bet it's only voltage, it's not a current. I mean, that's still not free energy, it's only a potential. There is no power flowing. It's only a potential difference. What we could do a potential for free energy. Bitluni's law. What does that say? The 80? What does they say? Please tell me it's good news. Does anyone have a link? 3 diodes. There we go. Output. Okay, so any positive voltage is going this direction. No, that's not even connected. No. Oh, sorry. I burped. I'm so sorry. Well, this is connected. COM is connected to ground. Is it? No. No, COM is not connected. So that would be just a flyback. What did I miss? First time change. Okay, Skylar. Was seen any but Twitch? What? Elliot, hey. Yeah, you missed how my new supercluster is just heating up. Okay. So output E. What is E? You're excited? Yeah. They're not working though. Oh, this is so. I hope the programmer would work. Or do I plan to run on it? You can center the PDF. No, because this is stupid. Built in. I can. Oh, alright. Yeah, welcome to Twitch. And it's parallel streaming on both. I can't. Oh, now I can. Yeah, hamburger menu. The name. So, this is what we do. Oh, you can even like spread it across multiple. Oh yeah, you're right. Oh, okay. I have 3 LV, so low voltage. So I have actually a different one on there. I have the part UL N2803 LV, low voltage, huh? Oh, or is it LW? No, LV. Naughty, yes. Here we go. Here is the proper data sheet. Oh, they have QFN. I should take that QFN. Yeah. All right. Any interest in going to it? Elliot, if I was invited, I might be thinking about it, but I'm not visiting it as a guest. It's like it's far away. The traveling is cumbersome. I don't know. Not sure yet. Probably not this year. When is it happening? Expert in Chinese. Yeah, okay, so what do we have? Yeah, that's some low voltages here. Yeah, minimal voltages. Yeah, I got that. We have some. Okay, yeah. I need a different sheet. English sheet. Oh wait. Reichelt has this. Oh no, that's A. July? Yeah, not sure. LV. Let me check if they have a. Yeah. Too poor for the plane tickets. Yes. Same for me. I mean, it's like $600 for the plane tickets, another $600 probably for the accommodation. I'm not sure if I really want to do this again. I'm more like, if I go, I would rather go to SuperCon because that's like my community. Open source would be nice once, but I wait for an invitation. Yeah, I have no datasheet for that except for the Chinese one. Sorry. But I'm using is it Lanke? Lanke manufacturer. Lanke. Another drink convention. Yeah, that's certainly interesting. Wait! Oh wait, that's a different part, but also LV. Different part though. Different part number. Yes, the compin is not connected, and I used it before on my matrix. Like, I used the chip with 3.3 volts on the magnet matrix. It's the same chip. It's not connected because it's not necessary. Translate the text on. Oh. Wait, where is it? I close it. I have too many. Where is it? Here. Pull-ups. What? No. It's. I think I used a different value there. You mean on the matrix? Yeah, because I have limited current. I have only 2 VCC pins on the matrix, so I can't drive like 16 LEDs at full power. That will be bad. That's why I used, but I think I used different values when I ordered the assembly. Ah, this okay. We need to. Pull down resistors because yeah, that's all right. It's not like it would harm it. They just boot up for a second maybe, and then whatever happens there. Maybe that's why it gets in a strange state. But okay, I hope the matrix doesn't blow up on me. Plug it in again. Okay. What? Who has to go? Oh, Eisenmochi, good night. Okay. Can you program only enable one MCU? That's what it should supposed to do. So with I can cycle through it, but I mean we can just turn on one and see what happens. I'm wondering if I just populate nothing but the connector, I might be able to still to talk to it. Debounce. Yeah, that's an LED driver. Wait a second. I have a suspicion. Huh? Okay. Here, the neighboring pins are just other grounds. Here the same. Now, there is no way of this being shorted in some way or form. Can you cycle each MCU high impedance off and ground it on? What does that mean? I'm cycling now with the button. Wait. We changed this but never used it because I think the conclusion was that it wouldn't beep because there is a voltage drop, and I think that caused it not to beep. Reset, yeah. Oh, we never, I think we might have compiled it, but never used it actually. So where is the supercluster 2? I wanted to, here, supercluster 2. We have user main. I will just code a little bit. So we have a startup, delay init, there is no usart. Oh wait, that's wrong project. Off state, yeah, that's what they are right now. And then you cycle each pin to on state. I could try inverting it. How do we test it? We could use an LED to test that. No, wait. We can test the voltage between VCC and the output pin. Okay, we can do that. It's too many tasks at once. It's not very structured what we do here, but I will test that. So let me unplug that. This is the matrix that heats up. I need to take care. Okay, so voltage. We measure it between actually 3.3 volts. This needs to be set here. And then I plug it in. And this might be okay, so yes, that works. Okay, so they're by default in an off state. Look at that, millivolts, and I need to press 14 times. And that's floating. And at some point we have 2.8 or something. Here we go, 2.6. Yes, because we measure between the low side pin and we have like 0.6 volts drop. That's why we have 2.6 volts. Yes, 2.6 is sufficient. I think it's even 2. Like, they run really on low power. Should be. I hope so, at least. 2.6 volts. Now, let me check that. But I think I run them. Myland. Is this a new project? Is it a new project? That's the question. A supercluster that we're working on for a while now. NMOS array, like, oh yeah, I should have used that. TPL 7407. Okay, let me check my Reichelt box. Oh, I doxed myself. Okay. what I ordered. I don't know what this is. So we have, what is HC273? What is, no, this is, these are some registers. HC153. Oh, that's multiplexers, then demultiplexing. Tip flip-flops with clear. Oh, okay. No, not helping here. I should have used like SMD MOSFETs for that, like little N-channel MOSFETs, and be good. Just on the limit. Uh-oh. Just beyond the limit. Made to below 2.7. Oh, what? .9 when it's using ADC. Oh, so many problems, peeps. I mean, we can just power them. We can short it and power. See what happens. TPL 7407. Okay, let me order it. I hope Reichelt has that one. But didn't I buy that? That sounds so familiar. 7407. .4 volts, yeah, I could do that. Assuming it's coming in the same package, yeah. Where do I get it? eBay maybe. God, Reichelt can't find it. It doesn't need to be TPL. I just will check for 7407. SN. Oh, we got something. So logic IC, but that's 5 volts. Hex buffer. But didn't I buy? This is the last time. Didn't I get something like that? I could just use as well like a buffer for that. I mean, I could use the octal D flip flop. No, I couldn't because that needs another pin. AC. What is AC153? Yeah, that's different package that I get here. Oh, they really want a lot of money for that. It's different package as well. What the F? 20 bucks? What? Crazy. No, that's a different chip. JC. Maybe at some point we need to work with what we have now. Oh no, I was recording that stuff. Oh yeah. Okay. So it might not boot up. That's what we get. I could power it from more than 3.3 volts. What's the limit on the CH? 32V 208. It's cursed? No, it's not. It's totally fine. It's totally fine because we can. Hey Christian, what are you doing? Oh no, is this like, yeah, that's the data sheet. Wait, where are the limits? Maximum ratings. 3.6 volts. Did I see it right? 3.6 volts. That's totally fine. We can even run it from 3.5. It's you're worried too much. Why did I take these stupid drivers for that? It's terrible. You hate it. Why though? This is what we love on this channel. Okay. I disconnected. Plug in the device again. It would be hilarious if we can actually. It would be hilarious if we actually can make it work just running it from a higher power. It doesn't heat up anymore. This is so cool. Okay, let me try the other one. Because I shaved off the mouse bites on the bottom. Maybe it's not tipping over and shorting stuff or whatever. I don't know. Okay. You want to be witness. What? That doesn't heat up either. Huh? What? Was it just shorting pins? Because it was wiggling or something. So strange. I just shaved off the mouse bites here where it might have been like tipping on that one. It's so strange. No. Okay. Can I flip to the MCUs? Okay, don't see anything. Reset. And wait, reset and turn that on. Minus 2.58. So one should be maybe running. Let's turn on our device here. I need a really long. This is not long. Where are the long cables here? What is this? This is just an... Oh! I like these. They have proper clips at the ends. Oh, this one seems to be broken. What? Why are you so skeptical? Always so skeptical about my endeavors here. Where is this cable maybe? Ah, damn it. It's the wrong one. It feels like I will short something if I use it like that. Alright, alright. I need some tape to insulate it. Wait, no. I will use this here. This is the long leads will be the fuses. Insulation tape here. Okay. Yeah, that are 003 ones, Dave. This is the new matrix. I mean the new cluster. Currently it's Aaron mentioned it's thermal TV because we had only like heating up MCUs. Look the size of that thing. Do you want to see a comparison with the old cluster? Where is my old cluster? Here. This is the old cluster that did the same thing, more or less. So, quarter of that. But we have slightly issues with the programmer board that you are looking at now. Okay, how do I get... I would need male to female wires here. Male to female. This is male to male. What? Where are my... jumper wire box? It's not that. It's hiding in plain sight, I have no clue. Why decoupling capacitor? What do you mean? Too much inductance? Are you worried? We have some serious capacitors here. We have serious capacitance there. That should be all right. Oh wait, I can take this wire. All right. I'm insulating every step of this contraption here. Graustreif, hello. No. I'm trying to power the board from 3.5 volts to get enough power to use the whatever to power the mini to power. Okay, wait, but this is like we won't be able to program anything. Oh, we can use just shared ground here. Okay, this is VCC, this is ground. Why did it disconnect? Okay. Huh? So you're going to feed to VCC of programmer. No, VCC won't be connected. I'm trying just to connect and see if we can get any talking to that. Alright. So we have, I will limit the current. Okay, it's running full. It's running full power at 3 volts right now. Oh no, I recorded all that shit here. Disable. I need to delete. TV output is in progress. Damn it. What is this? 32 minutes. Okay, there you go. It's deleting. Please wait, okay. Okay. Oh! This one is getting hotter. Oh wait! 53? Huh? Is that one running? Why is this strange mode? Battery low. Oh, foo. Damn it. I need to charge my phone. Why is this heating up so 50 degrees? I'm confused. Maybe what's happening, they're in a race condition because they don't get enough power. I just need to charge my phone. No, it's... Yeah, okay. Okay. What kind of mode is this? I want a different mode. Color. Huh? This is so strange. Okay. Huh? What kind of mode is this? I don't want this mode. Get me a different mode. Okay, yeah. Okay, I will turn it on and then let's see what happens. Oh! Now it's not overheating. It only draws 36 milliamps. Let's press the button. Okay. I might also record, okay? We're not overheating. I press the button. Nothing. No strange condition. $39. It's so strange. Sometimes it happens, sometimes it doesn't. Okay, I increase the voltage. Okay. 3.5 volts. Oh, the linky needs the ground of the linky needs to be connected to the same ground here. Because that will be strange otherwise. Power cycle. I reset it. Nothing. Okay. Now we can check, measure the voltage with the multimeter. Oh. Why does it show 0.7? Oh yeah, because the matrix is plugged in. Wait, no. Huh? What am I measuring here? Wait, this one? Oh shit. This was wrong. I need to connect it to ground. I connected the linky to the 5 volts. Thankfully there was no 5 volts connected at all. Okay, let me connect it to ground. Now we should be seeing something else. Okay, this is yeah. Here we go. No. Main MCU is the hottest thing with 27. Alright, I will just try to connect with the linky now. Power consumption increased. Did I just did I just delete? We have 29 degrees. Something's going on. Huh? The MCUs. Did I just do something? Okay, let's do a blink. Code erase flash success. What? Oh, we also need to. I mean, 71 milliamps is alright over there. If this works, I will eat my shoe again. What? No! Next stream is on Friday. Don't forget to tune in in infrared matrix. Yes. Tune in, enable. Okay, disable LED. Which one is it? GPIOA. Which one is it? Improv theater. What? Then Dave, tune in on Monday. I'm streaming on Friday and Monday as well. Okay, PA 0 and 1, so that will be 2. Huh? Why is there like... Oh, that's a toggle. Okay. Interesting. 2 and 2. Flash mode active. Bus receive. What kind of black magic is this here? C left behind, where? Oh yeah, here. It's Tracy. Okay. Unlock D7. We don't do this yet. Disable. Okay. USART. Nope. analog A2, no, A1, is it? A1. Okay. Let's compile that. And see if we can make one LED blink here. Should we clean it? I really, oh no, I'm recording for 6 minutes again, damn it. Okay. Let's program it and see what happens. It failed. Okay. Hmm. Program or verify failed. Okay, it doesn't work. Let me run the Linky tool. No. It's not able to connect. Is the voltage still too low? What was the highest voltage that we were able to do? Oh, you're right. Again. I did it wrong. Okay. No, not yet. Oh. Okay. I need to measure the voltage again. If we are... okay, what was the part? the maximum voltage on the MCU. 3.6 and we are at... Oh, it's maxing out. Uh-oh. Something's getting hot again. God damn it. Whenever one MCU, oh yeah. We got a new MCU heating up. A completely different one. Yeah. Here. Okay, now it's cooling down again. The other one is heating up now. Oh, interesting. You need to move the camera over or something because you can see. Okay, so this one might be the first one. This one is still cooling down, but this one might be running now. So let me try to query it. I need to record that, okay? So this one is cooling down, but the one on the bottom here, it might be just... Nope. Can't query it. No, this is just cooling down. This is from before. But the one on the bottom, I think this is running. If I switch it, that should be different one should be turning on now. Nope. Nope. Some strange state. Infrared rickroll, please. Oh wow. Okay, let me cool it down with my hand. This one as well, maybe. (40°C). I should have taken VCC, not ground, to cycle these things. Damn. What do we do now? Where's Fu, by the way? We need to play around with the matrix. what do I do here? Yeah, all the things look cool. Oh, it's dropped again. Okay, so apparently something's... When you cycle VPC while 3.5 volts. Yeah, actually it's 3.5 volts, but it drops because I have the current limit. Otherwise they would heat up too much. So it seems like they don't like to be not powered on correctly. I might want to boot them all up on startup and then let me think, and then turn them off afterwards. Oh, it's so difficult. Especially because I don't know what the issue is so far. Did you try Sonic on the Matrix? I mean, I can just switch the project and think about the other one for a while. The Matrix is so draining here. Okay, let me plug it in again. Nah, it heats up and drains current. What if I switch the thing here? Same. On the bear card, there is no bear card. I don't... Pogo pins. Oh, you mean like on the programmer? Okay, I mean... shoot. I could maybe populate that and program, but the ground of MCU card? No, I can't take off the MCUs. That's... I would be destroying a card. I will think about this thing and we can try on Friday. I think I will hack with yeah, that's what we can do here. Putting on the connector plugging in the card and only one VCC and one ground. Yeah, there is no one VCC and one ground. All the VCCs are shorted. Yeah, the VCCs are joined, and there is like, unfortunately, and we can only we can switch the ground like manually. Just we can short like this whole part here, or use a jumper for those to power up one MCU manually, not using those switching things here. That might help. I might even try doing that. Yeah, we can just remove everything here. Power it up from the link key here and use like a wire with a needle to switch through the individual ones to program them. If that works, just an improvisation. To the common backfeeding, yeah. I suspect to lift one pin. No, there is no pins lifting here. Shoot. Some backfeeding might be there. But if I boot them up all at once, yeah, that's nothing for the stream anymore. It's so sad. One chip. Yeah, there is no one chip only here. Okay. I need to pause that. I will hack something, try to program it. On the IR spectrum it's bright, yes. Okay, let me unplug that. I hope I don't destroy them by just testing and doing what I do here. What we can do now is we can play around with the matrix. The matrix. Okay, this project goes to the other side here. So sad. I would love it if it would work right away. Shall we change the LEDs to make them brighter? Because I got new parts. And oops, sorry, the barf came. Yeah, I will undo the matrix and we will switch to different. Also remove the programming connector because we don't need that anymore. So in our Reichelt box, we have 330, 1K, 100K, 100 ohms. That sounds about right. How about 100 ohms? Here, 100 ohms. We have also 47 ohms, but oh well, 100 ohms will be alright. We have also three. Do I have here? What is this? I have no clue what this is. Chip. Oh. Chip resistor without a label. What is? Oh, that's 330. Isn't that mentioned anywhere? It's not. This one. Uh, 470. Because I got some additional resistances, so I won't be running out. But this, I think I have 100 somewhere. I hope at least. No, this is 330. Damn. Where's 100 ohms? Here. Found it. 100 ohms. Nice, okay. So we can actually rework that. Wire. Okay. First of all, let me remove the programmer. We don't need that anymore. Let's remove that. Okay. Yeah, we don't need the programmer. Just wicked it off. What is with this? I think the first one is ground, that's why it's so stubborn. Okay. have the 470 ohms here, and we put on what is this? Boop, boop, boop. 100 ohms instead. I think I might want, yeah, I will try to hot air it. Who's there? So I'm just changing the resistors for the LED rows on the matrix for them to be brighter. Yeah. Okay, but now I need the resistors, single resistors here. Was? Who leaves me? Don't leave me here. Don't leave me alone. My friend. Yeah. Totally can understand that. Okay, two more. Okay. Let's see if it boots. Ah! What is with this stupid HDMI cable? It's probably just twisted a few times. Cluster debugging, no conclusion yet. I need to find a way to, I don't know, I need to fiddle around and maybe make a new board. That doesn't use those UML or what they are, because they're not very good. So I hope that I can present a better working thing on Friday. So Friday stream. Is this power delivery here? Yes, I hope so. Okay. Now, magic smoke or not? Alright, let's record in case, just in case. Lit up. Oh! Is it? Yeah, no. The current limiting is happening somewhere else. Yeah, I can safety screens. So actually, connect. Okay, connect and send frame. Yeah, it's not getting brighter. The limit is not. The limit is not set by. I don't care. Windows updates. It's strange. It looks even darker now. Is it darker? No. It's probably, you know, that was before we had like 4 times the resistance. It was like 470 ohms. No. Okay, I have like, I can make it brighter like that, but in comparison with the lights and so on, I mean, I can turn off the lights here in this room. I can't tell actually. I might want to. Yeah, here you go. How do we play the games? Eco matrix. Maybe I turn on different lights here. No, the back ones here. Yeah, that's dark. Doesn't help. Probably overloading. I would try to set up the shutter speed very high. Wait, to see. $2,000. Ah. The update rate. Oh, come on. Ah. Oh, you're trying to do that. That's not working. That's not working anymore. I can start the server though. On okay. Wait. What? Module not found? What? My Node.js server doesn't work anymore, what? Oh. Okay, here we go. Server is running. You can send frames again over. No, not in chat. Dutch. You need to go to. You need to go to the link bitluni.github.io / M.2 matrix. All right. Yes, the same program of the other day. That should be running. Oh, wait. When I connect, as soon as I connect to WebSocket. All right, here we go. I hope it's connected. Let me try here. Yeah. bitluni github IO M.2 matrix draw tool here. You need to connect to WebSocket though. Oh! Who's playing that? Block out. It's slow, but someone's playing that. Wait. Yeah, it's upside down. Are you running it on Python? Okay, so blockout is running on the matrix. I just... Oh, interesting. One compiler. I need to open this in the proper browser though. Can you try? Oh, it's in Discord as well. Okay. Here we go. That was showroom, wasn't it? Yes. What? Can't find it. Too many channels. Showroom here. Okay. Breakout. Oh wow. Food did actually a good job here. Dutch, is it you? Okay, let me clone that. Oh, that's... Oh, it's actually... Oh, yeah, I see what's happening here. The issue is that it's encoded wrong way around. It's rotated by 180 degrees. So this is Snake running currently. Let me change the code. Where is this breakout game? Generate frame. I see where it's. Okay, I can just. You're sending. We are concurring. Wait, draw. I can just. Okay, now we can send something. Create matrix. I try to find where it's sent to. Here we go. Oh, generate frame is always, it's copy pasted. Okay, let's see. Space Invaders. But you can't control it yourself, huh? It's just... It's the AI button, yeah. Okay. Code. How you can send? You can send by using that link and then connecting to the WebSocket and then send frame. Okay, let me just reload that. Okay, so yeah, so you can also receive remote image to prevent others overwriting your thing. Wait, how do we do that? Okay, so tutorial. Let me move that over here. Connect to WebSocket, that should be filled in correctly, and then just send to WebSocket. Can turn off receive remote image so others won't send you like happened to me now. So I will be just adding stuff. Oh, is this international karate? Someone sent that. It's better visible here. Nice. Oh, someone draw this rectangle. I can also send to WebSocket and change that. Right mouse button is second color, by the way, so you can erase stuff like that if you don't clear. That's what's happening. Hey, dude. Hi. I would. Sonic, are you still here? Because I have something that I will just forward to you. Maybe you can make it run. Here on Discord. Morn sent this to me. I'm not running Linux. I mean, I could. This is. Yeah, Puppeteer. Require Puppeteer. Is this like. Yeah, that's. Wait. That's Node. I could run this on this main server. But this is like, I don't know, require Doom or what? Let me show that. Can I show this? Let me download this file. Okay. So. Oh, it runs from like JS DOS. Okay, okay. It grabs play Doom on grid FPS 15. This is so crazy. So more and more. I never tried that. Let's see what it opens. Where is it? Did it open a browser window? Clone that. Oh yeah. It runs Doom in the browser. Yeah, or thank you for nothing. I don't care. Remove that. Yeah, I don't want that. I want... Why is this stupid message? I don't want this stupid message. Okay. Yeah, that's sad because then you can't do anything here. Oh. I can do full screen. Puppeteer. So we need to run it off Ubuntu. Or wait for foo. Hey, Nishai, is this your Doom? Fake Doom. Cute. Yeah. I was able to stream a few things, and I hoped like we would be able to. Hi was yours? Oh yeah, the blocky one. Yeah. I'm wondering if you can do. Oh no, you can't. You won't be able. What segmentation fault? What? Oh no. How do we? We could run Doom on another screen, a video. Oh, little hearts. 20-old year Debian installation. Maybe. Let me check if I can run Puppeteer on the main server here. Okay, yeah, I won't be able. Yeah, I can do another. Is Puppeteer Node.js package or npm, or is this like apt-get? Is this npm? npm. Okay. I try that if my Debian is allowing that, but probably not. Oh, it does. Look at that. It did. What did I? What? What happened? What? Yeah, no crash. And what else do I need? Const require, that's all, huh? I would, though, how do I don't know. Let me get it dropped the edge. Oh. Bitluni. Yeah. I don't know. I don't know what's happening there. I will try to upload that on and run Puppeteer into the abyss. File manager. And try to var Node.js and then upload. Oh, that didn't work. Upload to current directory. Okay. Upload it. Okay, now node draw. Yeah. wait, what? Oh, wait. What? Cannot find module puppeteer. Did I install it in root or what? Huh? What the fuck? Oh. Modules, puppeteer, browsers. Browser process. Oh, with no sandbox. Running as root. Yeah, and also it says running as root without no sandbox is not supported. That's cool. Okay. Yeah, so let's go. Let's run it. Node and then draw.js. Ah, could not find Chrome. Ah. But Chrome on Debian? It banned you. I don't know. I didn't ban anyone. It works still. Still working. So, what do we do then? Apt-get install. Are you connected to the WebSocket server? What, FF, what is? Browser launcher, Chrome launcher. Oh, wait. npx puppeteer browsers install Chrome. What? Wait, I need to run something like that. Huh? Oh shit! You're watching the Matrix, not the. What is this? A fountain? Tortoise? Turtle? What is npx? Okay, maybe. No, and Puppeteer browsers install Chrome. Or your cache path is incorrectly configured with Minecraft cache Puppeteer. Oh yeah, certainly. Is this some Japanese hiragana, a kanji that says insults in kanji? Okay, I can't run Doom here. Here we go, Enterprise. I like that. I just recording it. A little Enterprise. Alright peeps, I think that's it for today. Let's try. I hope Mormon comes on. And I mean, I can try to phases on what? Phases? We can always do like a screen grabber. That's quite easy, and let YouTube run in another window. I would just add this functionality. We can run it any times. I need to poke more and more. Alright, peeps. Thank you for joining the stream. It was a blast. I'm tired now. There are phases. Yeah, and I see you on Friday. Bye bye. Good night.